Today we like to discuss about the fundamental concept of electronics. This fundamental concept of electronics is very much useful for the student of physics, student of biophysics and student of electronics group, means those who are having the subject combination physics, mathematics and electronics as well. So, we discuss the complete syllabus of this electronics in different module. First module today I like to start the first module. The first module is electron theory. So, the electron theory we have to start with the concept of electron. So, electron, before going to electron we have to see the previous concept of the electron, that is the first name of atom was proposed by Sir John Dalton in 1804 in his famous theory of atomic theory. So, as per the atomic theory, the hypothesis of John Dalton, hypothesis of atom is number 1, neutral, means atom is electrically neutral. The second one is indivisible, atom is smallest entity of the material, it cannot be subdivided into other parts. And third and most important part of the hypothesis was free processing, that electron can this atom can take free process in the physical as well as chemical processes. And after the 96 year, this 96 year time is very important. We have seen in various different concept what is the importance of 96 years, but here it is after 96 year, that is 1804 plus 96, that is 1900. So, in 1900 AD, Sir J.J. Thomson discovered or named the entity is electron. Before 1900 AD, there are several experiments, discharge tube experiments right from 1880 to 1889, that is 29 years period, or last 20-year periods are very much important for discovery of electron, especially in reference to the discharge tube experiment. This discharge tube experiments. In this discharge tube experiment, there are several names as canal ray as one of the important concept that was later discussed. The third point is ion. Ion, the electrically charged atom, is called as ion. There are two types of the ions. One is positive, when there is a lack of electron then it is termed as positive, and the excess of electron then it is termed as negative. Then in 1911 AD, Sir Rutherford in the famous experiment of alpha scattering, through the alpha scattering he termed that there is a central part in the atom and that central part is positive and it was termed as proton. And then in 1932 Sir James Chadwick gave the name as the neutron. So, up to the 32, from this 1900 to 32, in the journey of 32 years, there are three fundamental particles: electron in 1900, proton in 1911 and neutron in 1932 are named. One important thing in case of the proton is, this is also sometimes called as canal ray because of it is positive nature, and this was proposed in 1885 AD is Goldstein. So, Goldstein, sometimes it is also termed as proton was discovered by Goldstein. So, the gold stand only due to the discharge TB experiment that was performed during the end of the 19th century or beginning of the 19th century, end of the 18th century. So, on the basis of these fundamental particles, electron, proton and neutron, there is a structure of atom. But before the structure of atom, the one of the very bright student of Rutherford in England, Niels Bohr, proposed the concept of the atomic model of Rutherford as Bohr objection, and he himself removed the Bohr objection by proposing some Bohr concept, Bohr fundamental postulates. And from that Bohr fundamental postulates, he proposed that there is a central part of the atom which is positive and the remaining part of the atom is hollow, and in which there are different orbits and electrons are moving in the different orbits. So, this is termed as positive part different orbits, and these different orbits have the electrons, and these are known as electron cloud later. So, these different number of the electrons, one very interesting concept in this corona pandemic is these electrons continuously maintaining social distancing as we are being said to everyone, follow the social distancing. So, for the sake of this part, electron is maintaining social distancing with the positive center of the electron nucleus. So, this is just a correlation of this time, that is 2020 to 1900s. But so, the structure is the positively charged, here it is nucleus, this nucleus is completely positive charge, and then there are several electrons are revolving in the atom in the outer space. These electrons, especially these electrons which are in the outermost orbit, electrons in the outermost orbit are termed as valence electron, and this valence electron determine the valency of the atom, which give the stability concept, of the atom. So, till date we have just coming to the structure. On the basis of this valency concept of the electron, we classify the materials in three part. Matters are classified as three part. Here it is conductor, then there is a semiconductor, and the third one is insulator. Conductor, semiconductor and insulator means there is availability of valence electron for free movement, the availability of valence electron for restricted motion, and there is no availability of the electrons for motion inside the material, then it is termed as the insulator. The properties that we have differentiate on the basis of these are: first, resistivity, so the resistivity is 10 to the power minus 7 ohm centimeter. Here it is 10 to 100 ohm centimeter, and this is very high, say 10 to the power 10 ohm centimeter. So, highly resistance. Then there is a temperature coefficient. Temperature coefficient is alpha. In case of the conductor, it is positive. here it is negative and this is independent. It does not depend upon this. The graph of the variation, if we take this one is a temperature scale and here it is resistivity. So, this is the positive trend of the variation. Here it is temperature, this is the x axis, this is the y axis. So, on the basis of x and y axis, this is the negative trend and here it is again independent. So, on the basis of this temperature coefficient, we have some concept and the number free electron. So, n in case of this one is 2, 10 raised to the power 28 per meter cube, here it is 10 to the power 10 per meter cube, and in this case here it is 10 to the power 5 per. The energy concept of the electron on the basis of the part is, fifth is energy band. Energy band in case of conductor, if this one is valence band EV, that is valence band which is fielded something like this, and this is EC, it is conduction band. That is, here it is conducting stage. So, in this case EV is greater than EC. In case of semiconductor, this one is EV, this one is EC, and this in this case EC is greater than EV, and in case of the insulator, this is EV, this is EC. So, this one is the energy band diagram. Now, the 6th is energy band gap. What is the energy band gap? Here energy band gap is 0, this is crossed, and in this case delta Eg energy band is EC minus EV, this is EC minus EV, and which is of the order of 1 electron volt. In case of insulator, this Eg is approximately 5 electron volt, that is very high. So, on the basis of the properties from the conduction, semiconductor and insulator, on the basis of resistivity, that is, this one is very low resistivity in case of conduction, in case of semiconductor 10 to 100 ohm centimeter, in case of insulator it is very high 10 to the power 10 ohm. In case of temperature it is positive coefficient, here it is negative coefficient, in case of insulator it is independent. So, graph of this resistance versus temperature is straight line and positive gradient, and here it is the negative gradient. Number of free electrons are very high in case of conductor, and in between the conductor and insulator number of electrons in the case of semiconductor. On the basis of energy band, this one is a very important concept regarding this, because the case of conductor, the conduction band is below the valence band, means the electron had sufficient energy to conduct the charges, to conduct the energy inside the material, that is conductor, and that is why we can say the gap is 0, there is no gap. Crossed band, these are known as cross bands. In case of semiconductor, yes, there is a finite band gap, that is higher band gap is EC, lower band gap is EV. So, EC minus EV is approximately, this one is 1 electron volt. This value will change from example other way, and in case of insulator there is a 5 electron volt, it is very high band gap, and these are the basic concepts. And the examples are here: aluminum, silver, gold, platinum. So, all the metals are good conductor. In case of this is silica, germanium and alloy, say gallium arsenide, and some organometallics are also be there. Here in case of plastic, wood and other materials are the example of this one is. Now, when we are coming closer to semiconductor, then the property of semiconductor, is especially governed with the fourth group elements of the periodic table. So, the fourth group elements are C is 6, 2 and 4, then there is a Si, this is 2, 8, 4, then the germanium, that is 32, 2, 8, 18 and 4, then Sn is 50, that is 2, 8, 18, 18 and then 4, and then lead Pb is 82, that is 2, 8, 18, 32, 18, 4. So, in this fourth group element, the peculiarity is the outermost or electron are 4. These are the 4. So, this particular block of the atom are termed as semiconductor, and these are conductor highly, and carbon is a very different kind of the material. Whole organic chemistry depends on the nature of the carbon. We have allotrope as the graphite as the diamond. Diamond structure is purely bad conductor insulator, and graphite is highly conductor. It is used for the electrodes in case of the silica material. So, this silica and germanium, has the concept and the band of the energy something like this, have the case, and this case is say the silica, this is germanium, and here it is silica and the gallium arsenide. So, on this we can specify this one is as a on the basis of delta Eg band gap 0 Kelvin, and this is room 300 Kelvin temperature. This value is 0.78 electron volt, this value is 0.272, this is 1.21 electron volt, this value is 1.11 electron volt, and here it is 1.48 electron volt, and this is 1.42 electron volt. So, these are the band gap of the semiconductor materials, which gives the concept of temperature dependence, that is from 0 Kelvin to 300 Kelvin. If we increase the temperature, the band gap will decrease. Band gap is decreased means there is a decreasing of this part, and one of them is here, it is EF, and this EF is known as Fermi level. Fermi level. After detail point, we will discuss that EF is equal to EC plus EV divided by 2, that is mid of the gap, that is Fermi. Fermi is something like this. So, for the first module today we have to just start the concept of electronics from the electron theory. On the next lecture, in the next module 2, I will like to discuss the important concept of formation of the band gap. So, this is all about the today this lecture. Thank you very much.